Welcome back to another video in our Android starter course. In this video, we're going to be talking about bitwise operators. And a bitwise operator is just an operator where you're performing work on some number at a bit level. So using the binary numbers, you're changing individual bits. So to get started here, I already have a bunch of code going through all of the different bitwise operators. And I've already compiled and run this on my emulator. And here's my output over here in my logcat window. So to get started, the first one that we have listed here is the left shift operator. So I will show you in Kotlin to do that, you do 8 SHL, which stands for shift left, and then however many places you want to shift it left. So here I have 1, but you could do 2 or 3 or 4 or whatever you want to do. So I will show you on a calculator. So this is our Windows scientific calculator. And if I have an 8, if I wanted to shift this 8 1 to the left, what that would do is it would take this 1 and put it there. And now you have 16. Now if I shifted it twice to the left from the 8 position, you'd have 32, and 3 times to the left, 64, and so on. That's where you're getting this 8 shift left 1 equals 16. Same concept with the right shift. So if I do 8 SHR, which stands for shift right 1, I'm going to get, here's my 8. If I shift that 1 to the right, I get 4. If I shift it to the right again, 2. If I shift it to the right again, I get 1. And then if I shift it to the right beyond that, I'm going to continually get 0 because now that 1 is gone. And then you have your, you also have an unsigned shift to the right and then a signed shift to the right. And the reason this is important is because if you remember when we talked about binary numbers, I told you that this last bit here is going to be reserved for your sign bit. So if I click 1 on that, that's going to give me my the lowest number I can possibly have, which for an integer is -2 billion. Now, if I was going to take this 1 and shift it to the right, using my unsigned shift, it's going to take that 1 and it's going to literally move that 1 and it's going to fill zeros after that. So if I do that, I'm going to continually get smaller and smaller, with the one exception that when I start with my absolute minimum number, I'm going to go from my absolute minimum number of 2 billion, and then I shift it up to 1 billion, and then after that it's going to be decreasing. But that first one, it increased quite a bit because we're going from negative to positive. So you may not always want this. So what they have in Kotlin, they have your unsigned shift, which is going to, if your number is negative, it's going to make it positive every time you shift it. And then you also have your signed shift. So if I do the shift to the right from here, you'll see that in Kotlin, if I do the minimum shift to the right, so I'm taking a negative number and shifting it to the right, I'm going to get this -1 billion instead of the +1 billion. So that's going to be the difference between the two of these, is the SHR, which is shift to the right. If I'm doing that on a negative number, it's going to pad the left with 1s. Which means I'm going to continually be filling up all of these 1s. But if I'm doing that on a positive number, it's going to not pad that with 1s. It's going to pad it with a 0. If I'm doing the unsigned shift to the right, rather. So that's the difference between those two. Then after that, you've got your AND. So let's look at what our code is doing here. So we have 1 and 13. So in binary, if I have 1, that's going to be 0, 0, 0, 1. And if I have 13, that's going to be 1, 1, 0, 1. So if I'm going to AND these two together, it's going to take every bit in each number and it's going to say, okay, if I have a 1 and a 1, we're going to leave it at 1 in the result. And if I have anything else, I'm going to set it to 0. So for these two numbers, if I'm going to AND 1 with 13, it's going to end up with just the first bit set, which is going to be 1 again. And that's because we have 0, 0, 0. So all of those are going to be 0. And then the 1 position, which is 2 to the 0, that first bit there is the only bit that's set in both of those numbers. Now, if I had all ones in the top and I was going to AND that, which is 15, if I'm going to AND 15 with 13, well, that's going to give me 13 again, because now I have every bit. So the first bit, we've got 1 and 1. The second bit, we've got 1 and 0, so that one's going to stay 0. The third bit, 1 and 1, so that's going to be 1. And the fourth bit, 1 and 1, so that's going to stay 1 again. Now, OR works a little bit differently. Essentially, your OR is going to say if either the first number or the second number has a 1 in it, then we're going to set it to 1 in the result. So if I have, like in my code here, I did the OR of 1 or 14. So there's 1, and then 14 is going to be 1, 1, 1, 0. So 1 ORed with 15, you're going to come in here, you're going to say the first bit, well, there's a 1 in the top and a 0 on the bottom. So the result's going to have a 1 because between the two of these, one of them had it. And then the second bit, same thing, 0 and 1. Well, one of them had a 1. And then the third bit, 0 or 1. So that's going to be 1. Fourth bit, 0 or 1. So that's going to be 1. So we are going to end up with 1, 1, 1, 1, which is 15 in binary. Now, if, say, I had already 1, 1, 1, 1 right there, and I'm trying to OR that with 1, so because if I have two numbers and they each have a 1 in this bit spot, with the OR, that's still going to leave it at 1. So 1 ORed with 15 is still going to give you 15. 1 ORed with 1, 1, 1, 1 is still going to give you 1, 1, 1, 1. If you don't want that behavior, there's something else called an exclusive OR, which in Kotlin, you use XOR to represent that. So for the exclusive OR, what that says is if either of these, but not both of them, have a 1 in this position, then put a 1 in the result. So in this case, if I was to do an exclusive OR instead of just an OR, we are gonna take that first bit, and we're gonna see 1 in the first number, and then we're gonna see a 1 again in the second number, which means in the result, we're gonna set that to 0. And then if I was to do keep going with that, 0 or 1, well, there's only 1, so that'll be 1. 0 or 1, again, only a single one of those was with a 1, so that's 1. And then 0 or 1, only a single one had the 1, so 1, 1, 1, 0. Now, there's just one more operator to cover here, and that is going to be your, the only operator that we have left to cover is going to be your inverse operator. So if I have the number 3 in binary, and let me just change that to a D word because that's going to be the same size as our integer. So if I have a 3 in binary, which is just 1, 1, and I run an inverse on that, what that's going to do is we're going to look at this number, and anywhere I have a 1, we're going to set that to 0. Anywhere where I have a 0, I'm going to set it to 1. So in this case, what that's going to look like is right now we have a lot of zeros followed by 2 1s. When we run an inverse function on this, we're going to have a lot of 1s followed by 2 0, followed by 2 zeros. So this is what your inverse is going to look like, which is where you get 3 dot inverse equals -4. Because now we have the 2 bits that were positive, that were set to 1 in our 3, these two are set to 0, and everything else is set to 1. So that is really it for all of our binary operator, or our bitwise operators rather. Hopefully this video was helpful for you, and you won't use these a whole lot, but definitely there's occasions where you want to use these and you'll need to know these and be able to use them. So if you found this video helpful, go ahead and like and subscribe, and we'll see you in the next video.